use the tools in chemistry, right? Right now, just considering your skill enhancement abilities, different courses are organizing add-on courses, right? So that once you complete your graduation, you do have certain kind of skills, and when you go to the other fields, you can prove yourself, right? So similarly, on that basis, in chemistry we have started one add-on course, that is application of software and tools used in chemistry, right? So that is the add-on course we are starting in chemistry, right? And in this we'll discuss about the different softwares, or you can say different tools that we use in chemistry to describe the chemical reactions, right? So I will start with a simple reaction, and then we will discuss how we can use various tools or softwares, right? So you can see this is one of the reaction where this is the reaction, you know. Have you studied about reactions, right? Just conversion of benzene into phenol, right? Or conversion of alcohol into aldehyde, right? Or conversion of alkyl halides into alcohol. That we have studied, right? Now, when we do a reaction, right? When we do a reaction, how we do the reaction? We take the reactant, the starting material, the reactant, right? Then we add some catalyst or reagent that is responsible for converting the reactant into product, right? So here you can consider this is the reactant, these are the catalyst or reagent that we added in a reaction. We carry out reaction by adding starting material or the reactant, then catalyst, reagent and solvent, and provide certain conditions to form the product, right? So now when we did the reaction, right? Now once the reaction is complete, now here comes the point, how will you analyze that product has been formed, right? What you will do? You will use basic analytical methods to identify the product, right? The product identification you can do with various analytical methods in chemistry. There are a number of analytical methods like TLC, chromatography, or like GCMS, right? So in this case, here, in this particular paper, you can see here, we have described this reaction by writing this in this proper, right? You can see the reaction, the reactant and products are written in appropriate manner. Because when we draw these bonds or these structures by hand, they do not look like this, right? So for this purpose, we need to use some software, right? So here, to draw these structures, the software that is used for drawing this structure, that is known as Chemdraw. That is known as Chemdraw. Signs are like this. Chemdraw. Just to draw the structures in an appropriate way, right? Moreover, for drawing these structures, after this, when we did the reaction in chemistry, there are 2-3 methods, 2-3 steps in synthetic chemistry that are utilized to identify the product, right? We carry out the reaction, we analyze the product, and then we isolate the product. After the reaction is complete, the product is isolated. You see, you have performed in BSc first year the purification of urea or oxalic acid, right? You have performed that reaction. What you did? You took the impure sample of urea or oxalic acid, right? And then you did the experiment, whatever the procedure you followed, and you did the experiment, and then you isolated or carried out after filtration, you placed the filtrate in the china dish, and then let the solvent to evaporate. After the evaporation of solvent, you found the crystals, white crystals, right? So that is how you said that these white crystals correspond to urea or oxalic acid, right? Now here in this case you started only with urea, that's why you said that the product is urea. But let us suppose you started with 2 different reactants. One was urea and other was oxalic acid. Then there is formation of urea oxalate, right? In that case, you have to find out what is the product that is formed, right? For that, you need to analyze the product, right? You need to analyze it. So the analysis of the product that you synthesize while carrying out the reaction that analysis can be done with various analytical techniques like GC, GCMS, LCMS, or mass chromatography, or or you can say mass chromatography, or mass, that is also known as mass spectrometry, or UV, IR, or NMR spectroscopy. Right? So in synthetic chemistry, NMR, which corresponds to nuclear magnetic resonance, that is one of the most utilized technique to identify the structure of an organic compound. Right? Whatever this UV, IR, and NMR, this is the syllabus included in BSc third year. You will study about that in detail. Right? Here is the basic knowledge that you must have. So once you go to your research or higher classes, you have the basic idea. What is NMR? What is UV? What is IR? Because this is the platform you can utilize. Because when we went to the higher classes, we were not having this kind of knowledge. What is UV, IR, NMR, and how these techniques are used to identify the structure of the. But for you people, we are providing this platform, and you should use this platform as an opportunity. Right? So here, once this reaction is done, let us know the different products formed over here. So here these products are characterized with, there are two different techniques. One is analytical techniques and other is characterization techniques. Analytical techniques are to analyze the product, what is the product form, and characterization is technique, whatever product form, what is the structure of that product. Structure confirmation of the product in organic chemistry is done with the help of NMR, nuclear magnetic resonance, UV or IR. Nuclear magnetic resonance gives about the information of carbon-hydrogen skeleton. You know, in organic compound, carbon-hydrogen skeleton is the backbone of each and every organic compound. Right? You can see in human skeleton, you see the bones, that is the backbone. The backbone is the main structure which is responsible for holding the structure in a proper way. Similarly, in organic compound, carbon-hydrogen backbone is the main skeleton of organic compound. Right? You know glucose? Glucose, you know? What is the formula of glucose? C6H12O6. That is the carbon chain of 6 carbon, right? And along with those 6 carbon-hydrogen bonds are, or hydrogen or hydroxyl groups are attached to the carbon. So carbon-hydrogen bonds represent the main skeleton of organic compound in each case. So here the identification of the organic compound is done with the identification of number of carbon-hydrogen bond or type of carbon-hydrogen present in organic structure. So for that we use NMR. Now when we carry out the analysis of this organic compound with NMR, then we need a particular type of software to analyze the data. NMR is a spectrum, we can say instrument where we give our sample for analysis. Whatever crude data or raw data that we get from the instrument, that is analyzed with the, again here we need some software to analyze the data. Right? So here the software that we use for the analysis of data is, you can use like Masternova, that is one of the software for analysis of crude data from NMR instrument, or TopSpeed. Right? These are the two softwares that we can use. So here, first of all, today we will discuss about the drawing of structure using Chemdraw. So here I have drawn this structure using Chemdraw. You can see how the beautiful these are looking. Right? Moreover, if you see, we can not only draw the structures, we can also write down the structure as well as the mechanism of reaction by using the Chemdraw. Right? So now I will tell you how to use Chemdraw to write down the structures. So this is the software, Chemdraw software I have installed in my laptop, right? And by using this one, I will tell you how to draw different structure, right? Let me just do the page setup. Right? Now let us suppose you have to draw the structure of benzene, right? So what you will do, here you can see different structures are given. Yes, sir. You can see here different structures are given. So you can directly click on this one and you just click over here. You will get benzene structure, right? Now you want to convert this benzene into phenol. So how will you do? You can see this represents single bond, and this represents single bond, this represents double bond, triple bond, right? So here, in case of phenol, what you do, you place your cursor over one of the carbon atom of benzene ring, and you will get a single bond. Now, if you want to write down here hydrogen, because in case of phenol, the hydroxyl group is attached to benzene, right? So you will take the text box from here, you place the text box over this edge, and you will write on OH. So that's how you can write hydroxyl, right? Is that clear? So this is how we can draw the structure. So this is a structure, we can say here you can directly take the module. However, let us suppose you want to draw simple hydrocarbon or glucose, right? So what you will do, simple Fischer potential formula of glucose, what you will do, you will select single bond from here, one single bond, then at the edge of this single bond you again place another single bond, then third, or you can say here you can write carbon, right? Once you write down the carbon, just one second, what you do, you place a single bond over here, right? You write down the carbon over here, then second carbon, right? Then one more bond over here, then again carbon. This is the simplest way, otherwise other way you can use as well, right? Then again carbon, 4 carbons, then it is 5th carbon, and then it is 6th carbon. You know, in case of glucose, the formula is CH2OH. There is one primary alcohol and then secondary alcohols as well. Now what you can do, you can write down, if you draw the single bonds, hydrogen will be eliminated automatically. You know, in a carbon atom, you can have only 4 bonds, right? If there are less than 4 bonds, then carbon will have either positive charge or negative charge. That means carbon will be either carbocation or carboanion, right? So here, if you draw these structure like a single bond like this, hydrogen will be eliminated. And you know, in case of glucose consists of aldehyde function group and alcoholic function group. So here you can write hydrogen. So in case of glucose, you see this side here it is OH and here it is H, right? We do have alternate position H and OH. So here it is H, here it is OH. Then again here it is OH and here it is H. And here it will be H and that side it will be OH. So this represents your structure of glucose, right? So here, this is how you can draw the structure. Now you see, what is the other application of this Chemdraw? You can see here, let us suppose I am drawing simple methane. I am writing here simple carbon here, and I am attaching 4 bonds to this carbon. You see, whenever carbon is not satisfying its valency, you can see red color will be there. That means structure is not drawn properly. Whenever red color is there, that means structure is not drawn properly, right? So let us suppose I draw here CH here, CH here, CH here, and CH here, right? So this is the proper way of writing methane. You can, if you don't want to write in elaborative way, you can just write CH4, right? Now this is not correct representation because 4 must be as subscript. So for this purpose, you just click on this CH2 and it will be converted into simple CH2, right? Is that clear? Moreover, when you write a reaction, let us suppose you are writing, there is the provision of eraser. You can just erase it like this, or you can just select this one and then delete this one, right? From delete one. And there is one benefit. There is the provision of going forward and reverse, right? From here, or you can use the shortcut key, that is Ctrl Z. right? Control C, Control V, Control Z. Both all these type of commands work in Chemdraw, right? So now let us suppose you are converting this benzene into phenol, right? So how will you write this reaction? This is the benzene. You will select one of the arrow from this side, right? So this is how you can draw the arrow, right? And this is benzene, or more appropriate way. Now here, what are the reagent required to convert this benzene into phenol? That reagent you can write over here, right? This reaction proceeds two step. This reaction, it is not possible for directly conversion of benzene into phenol. It requires conversion of benzene first into aryl halide, that is benzyl, you can say chlorobenzene or bromobenzene or iodobenzene, and then aryl halide can be converted into aryl alcohol, right? So here we can write the reagents, right? Moreover, you might have seen, or one more thing that I want to explain to you, that is, let us suppose I am writing here CH4, right? That is methane, right? Now methane, you can see here, it is you can also utilize the 3D model to view the structure. Yes, you can view the structure in 3D model as well. This is how the CH4 looks like. It is not like, you see, previously drawn structure of methane, you see here, I have drawn here like, in the books, methane is always drawn like this, right? Methane is always drawn like this, two bonds in a vertical position and two bonds in horizontal position. But in reality, the structure of CH4 is tetrahedral. Because in methane, the hybridization of carbon is sp3, and tetrahedral structure looks like this. It is not like simple two vertical and two horizontal bonds. It is not like that. Geometry is like this, and you says that in tetrahedral structure the bond angle is 109.5. It is not exactly 90 degree. You can see over here. If you are looking at this structure, you might be seeing that the bond angle between this carbon hydrogen and this carbon hydrogen bond is 90 degree. But that is not the case. You see, you can visualize. That is the benefit of using this software. You can visualize the structure in 3D model to understand what is the actual structure, right? So you can see here, this is how the tetrahedral structure looks like, right? You can also select this benzene. So phenol structure looks like this. He says that benzene is planar in nature. You must have studied in BSc first year Huckel rule of aromaticity. Benzene ring is aromatic in nature because it follows Huckel rule of aromaticity. It must be planar in nature and it must consist of 4n plus 2 pi electrons. 4n plus 2 pi electrons, benzene consists of 6 pi electrons and it is planar. Planar, you see here, this benzene is looking like a single plane, right? Whereas you see, this CH4 is not planar. Few bonds are in one plane, few bonds are in other plane, right? You see, this bond is one plane. These three carbon, this hydrogen, this carbon, and this hydrogen, they are in different plane. This carbon, this hydrogen, this carbon, and this hydrogen, they are in different plane. And whatever reverse one, this hydrogen, and this carbon, they are present in different plane. However, in case of this phenol, you see, all these atoms are present in single plane, right? That's why benzene rings or the compounds containing benzene rings are aromatic in nature because they are planar in nature, right? And one more thing, one more example you might have studied, like in Huckel rule of aromaticity, this compound is not planar in nature. If you place some methyl ring over here, or methyl this, if you place some CH3 over here or some methyl substance over here, then this molecule is no longer planar in nature. You can see here how the structure is One benzene ring is lying in one plane and other benzene ring is lying in other plane. You can see here, this benzene ring is in one plane and this benzene ring is in other plane. You can see here. Is it visible? Right? However, if you consider this single benzene, it is planar in nature. All the carbon-hydrogen bonds and cyclic structure is in single ring. Is that clear? So that is another utility of this Chemdraw software that you can use to visualize the structure. Sometimes it is necessary to visualize the three-dimensional model to understand the actual structure. And if you are capable of imagining the structure in three-dimensional model, you can describe the number of properties, right? Like we say that in case of NH3, you know NH3? What is NH3? NH3 is ammonia. So from here you can see in ammonia there is one lone pair, right? So from this side we can select one lone pair like this, right? Now it says that structure of ammonia should be planar, but it is not planar. It is pyramidal shape, right? The structure of ammonia is in pyramidal shape. So is it like pyramidal shape? And whatever lone pair law that lies over here, right? Pyramid you see? Have you seen any time the image of pyramid? You must have seen, right? So this is how the structure of ammonia looks like, right? Now if you look at the structure of water, also write like this and then convert it like this. So this is how the structure of water looks like, right? Here red color represents oxygen and white color represents hydrogen, and the shape of water molecule is V shape, right? And there lies the two lone pair, one lone pair over here and other lone pair over here, right? Is that clear? So this is the CAD 3D model. Moreover, by using this software, you can also write down the geometrical isomerism as well, or stereoisomers. You can also write down the structure in stereoisomeric form. You might have studied stereochemistry in BSc first year, right? So if you look at the structure of this one, let me write down one structure. One is suppose here it is hydrogen, here it is bromine, here it is OH, and here it is, let us suppose, CH3, right? Now you see, whatever central carbon, that becomes chiral carbon, right? Chiral carbon means the carbon which have 4 different groups attached to carbon. And you see, in stereoisomerism, the structures are represented like this. Some bonds are represented in solid form and some bonds are represented in dotted form or solid wedge, right? So this represents, you can say, you might have seen, sometimes structure is drawn like this. Whatever this represents, the bond is lying towards observer and this dotted structure, dotted line represents bond is lying away from the observer, right? So here, look at the 3D model of this one, the structure looks like this. This is the chiral carbon, right? This is the carbon carbon. One side bromine, one side hydrogen group, one side CH3, and this side hydrogen. This is how the structure looks like, actually, right? So we can also draw stereoisomeric structure using this software, right? Is that clear? Now, here, moreover, whatever structure you have drawn here, that you can copy the structure into Word file as well as into PowerPoint presentation, right? So for this purpose, let me show you a few PowerPoint presentations where I have used this software to draw the structures, right? Like, let me go to chemical kinetics first, right? I have prepared some presentation of chemical kinetics that we studied in BSc first year, right? So this is the basic information that I have drawn in PowerPoint presentation. You see here, this is one of the explanation for zero order reaction, then example of zero order reaction. Whatever this structure I have, you see, structure is looking very nice, but this structure is drawn with the help of Chemdraw. How it is done? If you just look at this one, if you just do the right click and then Chemdraw drawing object, you can edit or open. If you open this one, this file will open in Chemdraw. So here, whatever these blue color spheres that I have drawn from here, right? This is the one of the sphere that I selected. Size I can choose like this just by moving the cursor, right? Let us suppose I choose this side. Now you select this one. Color you can select from here. Color you can give this one, or if you want to give other color, you can give this color, or if you want to give other colors, then you can use either color from these boxes, or you can customize the color. Customize the color from this side. You can choose any color like this one. If you wanted to select this color, green color, either light green color or dark green color, you can move the arrow from this side, right? And then you select this one, so this one will become like this, right? So this is how you can select the colors, right? Now after closing this one, so then I will press Control Z so that presentation is not disturbed. Moreover, these mathematical expressions, you can see here, they are written in more whatever. You see here, whatever these mathematical expressions, they are not written symmetrically because they are not written by using Chemdraw software, right? However, if you see these mathematical expressions, they are written using Chemdraw software. You can write these equations in Word file, but it is difficult to write these equations using Word file. Have you any time used MS Word? Yes. In MS Word, you can write these equations, but it is sometimes difficult. But here, using Chemdraw, it is very easy to write out these chemical equations. You just open it. You can see here. You can get these symbols, infinity sign, from character map. There is one tool that is character map that you can get from here. View. You just go to the view option. You can just get the character map. This one that I have clicked. That's why it is appearing over here, right? So using character map, you can get different symbols from here. Is it visible? Yes. Everyone? Different symbols you can select: alpha, beta, delta, epsilon, phi, gamma, eta, anything that you can get from here, right? Then you can get the numeric numbers as well here, right? So whatever symbol you require, that you can get from here. Not only symbols, you can also get the symbols from other language, right? By using Chemdraw, right? So here it is easy to write down the chemical equations by using Chemdraw. Is that clear? Yes. I'll tell you how to write these equations. I have given you a laptop. After this lecture, you will try to write the structures as well as the chemical equation, right? So this is one. Moreover, you see here, not only you can just write down the chemical equation, you can also make it more beautiful or more interactive. If you go to the Chemdraw file, you see I have written this chemical equation, but in the background I have given some color. So how that color you can give just by selecting these shapes from here, right? Therefore I selected this shape, right, like this, and then color I can select from here. So, first I need to select this one, and then color you can select from here. So it looks like this, right? Then whatever this shape you know, how to draw the shape, how to color the shape. Now whatever this shape that can move to the front or that can move to the back side of the text. Right? Is that clear? Moreover, sometimes few texts you need in the faded way. So what you can do, you just go to the color, you can select black color, or you can just select black color, and black color you can select in the faded way. So you just one second. You can just go to this one, define custom color, like this. So sometimes few points you might have seen in some presentation, few words or few figures are written in the faded way. So that's how that you can do with the help of Chemdraw as well. Right? That is, this is of significance, this is of less significance. In PowerPoint presentation, or you might have seen in the books, sometimes few words or few lines are written in the faded way, and some few lines are written in the dark color. Right? So that is what you can do with the help of Chemdraw as well. Moreover, it is not only to write down the mathematical expressions with the help of Chemdraw. You can also draw the figures as well. So that is what I'll show you in the next PowerPoint presentation. Let us suppose in BSc second year there is syllabus related to solutions, right? BSc second year, yes, solutions. PowerPoint presentation related to solutions. So not only simple mathematical expressions you can write with the help of Chemdraw, you can also draw the figures or curves, right? So you see, this is the diagram I have drawn with the help of Chemdraw. How I have done this one? You see here, just right click and then open it. It will get open in the Chemdraw file, right? Now, how to draw this one? How I selected this one? If you just go to yes, if you select this line, yes, you can select line from here. Line you can select from here, then one line from here, one line from here, right? In this way, now you can place the line by selecting these two, close this one, or close one, right? This is how you can draw the box, right? And whatever these lines I have drawn, this line you can also bend this line as well. Thus, by selecting from the center, you can also bend this line, right? Like this, in downward direction or in upward direction. Moreover, you can color these lines. Just select this line and you can color from this to look the graph more attractive, right? Not only you can draw the solid line, you can also draw the dotted line as well by selecting from here, right? You select from here, and then you can write whatever these dotted line I have drawn from here, right? They are directly drawn from the Chemdraw. Is that clear? You see, why I am telling you all these information, because sometimes in future, let us suppose I give you some assignment and that you have to prepare in Word file and you have to draw the structures or graphs. How will you do? You have to use this software, right? Is that clear? So, if you are capable of using this software in an appropriate manner, you can prepare your presentation in more appropriate, right? And do not consider this that you have to study all these things. This is just to enhance your skill. Is that clear? So not only mathematical expression, you can also draw the graphs by using Chemdraw. Like I have drawn this graph. These are just I have copy pasted from somewhere. Like these graphs. You can also change the background to make the graph look more attractive, right? This syllabus you will study in BSc second year about solutions, right? Moreover, if you see, let me go to BSc second year, carbohydrates. This is carbohydrate presentation I have prepared, and here few structures I have drawn with the help of Chemdraw, You see, these structures are not drawn with the help of Chemdraw, and they are drawn inappropriately. You can draw these structures, or you can draw these chemical equations in Word file as well, but they do not look appropriate. You see, there is huge gap between this line and otherwise it should appear as simple arrow, right? However, if you see the same structure, same kind of structure drawn with the help of Chemdraw, it is appearing a proper structure, right? So you see how I have drawn this one. So right click. This is structure I have written. These brackets you can choose from here, right? To place these brackets you can choose in pair as well, either single bracket or in pair. You can choose in pair, then two brackets will be like this, or else you can choose the single bracket as well, right? You can use this curved bracket, or you can use the square bracket, right? Or you can also utilize the curved brackets. You know, in mathematics, three types of brackets are there: square bracket, simple bracket, or curved bracket, right? So that you can use from here. Moreover, beside these simple structure writing, you can also draw the structures, or you can also write down the mechanism of this reaction using Chemdraw, right? Whatever this structure I have drawn, or this mechanism I have drawn with the help of Chemdraw, right? Whatever these reactions, this reaction is also written with the help of Chemdraw, right? How I have done this one? You see here, what I did, how I have done this one. Glucose is written over here, and I selected the text box, and I have written cyanohydrin, oxime, or phenyl hydrazone over here, and these are also written with the help of text box. And how I have written these arrows like this. First I selected this arrow over here, one arrow over here, one arrow over here, and then I selected one line, and that line is placed over here, right? That is how this structure is drawn. You see, this is the mechanism I have drawn. Now you see, it is easy to write down the simple arrows, but how I have written like this. To write down this one, what I did, I selected one square bracket like this, or simple bracket like this, and then I selected one arrow, right? And then by selecting from the center, I just tilted like this, and then attached this arrow over this bracket. Then you can get this dimension, right? Is that clear? Moreover, you might be saying how this is drawn. So this is drawn by selecting one of the curve, right? Now you can also select this one from the center. Sorry, you can just increase its size, right? Please select from here. It can be stressed. It cannot be bent, right? So this is how you can write down this type of structure as well by using Chemdraw. And one of the these mechanism, I just told you how to write down this mechanism. In many books, you might have seen to show you the other application of this Chemdraw software. You see, this mechanism of this reaction is also drawn with the help of Chemdraw. Now I told you how to draw these type of arrows, right? By selecting tools from the Chemdraw, and you can easily draw this mechanism, right? So I guess
So you can also show them the biopolymers wala section jo
Yes,
tha na?
yes, yes.
And orbitals.
Yes. Let me show you some other points. In sometime when you write down, when you write down some structure, you have to write down. Let us suppose you are giving a presentation, you are making a presentation, and you need specific type of symbols in a presentation. So you can, if you want to draw some ribbons, then you can also use those symbols from the Chemdraw tools, right? So if you select from this one, it will appear like RNA or DNA type, right? That you can directly select from here. Moreover, then amino acids, like whatever amino acids in written you can get from here, or you can get from here as well. Carbon cylinders, right? These are the specific tools. Then you can get these human structures, right? If you need the structure of human brain, like this is related to anatomy, right? You can get stomach, you can get brain, you can get human body, right? Or different parts of it, right? You can also get animals. If you want to represent different animals, then aromatic structures, like you can get aromatic. You see, over here only few aromatic structures are here. If you want other aromatic structures, you can get from here, right? Aromatic structures, like this represent fullerenes, right? Or benzene. Sorry, this is not benzene. This is 1,3 cyclodiene, right? Cyclohexadiene. Then you can get bicyclic compound. You can get basic instruments. This represents, you can see here. This is beaker, syringe, then dropper, scissor, right? Number of other things are there. Like this is the weighing balance, right? Magnetic stirrer. Number of things are there that you can get from these tools. Then you can get bioarts, then bugs. Then you can get the other structure, like you can see here, titration flask, round bottle flask. Then these are the condenser funnel you can get. These are the conformers. Then cyclic rings you can get. DNA structures, functional groups you can get from here. Then hexoses, this represents the carbohydrate structures, right? Then you can get these microorganisms from here. Then nanotubes, organogels, phenyl rings, polyhedra, then polypeptides, RNA templates, shapes, different shapes. If you want different shapes in a particular presentation, then you can get from here. Then stereocenters and supramolecules. These are the additional tools that you can use by using the Chemdraw software, right? Is that clear? So this is all about how to use the Chemdraw software for writing different chemical reactions, mechanism, or making different writing mathematical expressions in physical chemistry as well, right? So now, moreover, one more thing, by using this Chemdraw software, you can let us know this is methane CH4. Just going to this, if you see, just going to view, and you can get show analysis window. So if I just go to view and show analysis window, and if I go to show analysis window, it can give you the molecular weight of this compound as well, right? This is methane, molecular weight is 16. We consider 12 corresponds to carbon and 4 corresponds to hydrogen, right? So that we can get from there. So just let us know this is glucose. If you select glucose, it will give its molecular weight. So from analysis window, you can get from here. So here, just by now, this is the benzene. As if I select benzene, you can get its molecular weight, and you can get the molecular formula as well, right? By using this software. And element, it also gives the information about elemental analysis. How much percentage of carbon is present, how much percentage of hydrogen is present in benzene. Elemental analysis it also gives, right? So that is the another application of this Chemdraw software, right? So now I will ask you people to use these laptops to draw the structures, right? So I will give you structure from over here, and you have to draw those same structure by using these lines. Are you ready? Ready to use? Okay. You can turn on this laptop.